Okay guys, we've been learning a number of formulas, and now we're going to learn where we can use these formulas to verify properties of geometric figures. So there are lots of different questions we can do that involve using these formulas to verify geometric figures. So I've got a list here, so you could use it to show that a quadrilateral with certain endpoints is a trapezoid, verifying that a point is on the perpendicular bisector of a line segment, show the diagonals of a square bisect each other. A lot of the terminology, it's going to be really important that you understand what that terminology means. So you can always check the glossary in the back of the textbook if you're not sure what these things actually mean and what their characteristics are. So it's really important that you come up with a plan of attack when you're doing these questions. So let's take a look at the formulas that we've got. So we're going to call this our toolkit, and you'll be able to have this page when we do our test on this unit. And here we've got a list of things that we can use each formula to find. So slope, we can help to show that things are parallel or perpendicular, and we know that we use that to help find the equation of a line. Length of a line, we can use that to figure out what kinds of triangles or quadrilaterals we're dealing with. So we've done some questions like that, trying to find if it's scalene or isosceles or equilateral. Midpoint, so anytime you see the word bisect, then you're talking about the midpoint because you're cutting something into two equal parts. And we've got our three different versions of our equation. So we've got slope by intercept form, standard form, and then we use this form to find the equation of a line. All right, so we're going to do some examples here, and you can see how we put these to use. So first example here, find the perpendicular bisector of the line segment with those endpoints. Now here they want us to find the equation of the perpendicular bisector, and I'm going to call this point A and point B just to make life easier for us. And I would suggest that you sketch a picture of what these things look like. Now it's not crucial that I draw this particular one on the graph. The important thing to know here is that I've got a line with endpoints A and B, and this line is called the perpendicular bisector because it cuts the line AB into two equal parts. So this point here is the midpoint of that line, and because this line intersects AB at a 90-degree angle, then that makes it a perpendicular bisector. So this line here is a perpendicular bisector. So we're trying to find the equation of that line. So for the equation of a line, we need slope, and we need a point. So for the point, as we can see in our diagram, the point that's on the perpendicular bisector is the midpoint of AB. And the slope of the perpendicular bisector is negative reciprocal of slope of AB. So this is kind of my plan here. And then I'm just going to go ahead and follow through on that plan. So my point A is 5, negative 4. My point B is negative 7, 8. So let's find the slope of AB to start with. So 2 minus y1 x 2 minus x1. I'm just going to pause it here and you guys can catch up once I've written this stuff down. Okay guys, so you can see I've calculated the slope of AB to start with. And the slope of AB ends up being minus 1. So if I do the negative reciprocal of that, the slope of the perpendicular bisector is going to be 1. So I've got the slope that I'm going to use. And then to find the point, the midpoint of AB is negative 1, 2. So now I've got a slope and a point that I can plug into the equation, find the equation of the line, and I've got it written in slope y-intercept form and standard form here at the end. All right, so now we're going to look at example 2. It's got a bunch of parts to it. So we're going to start with part A here. So part A, we're trying to prove that STUV is a parallelogram. So I'm going to do the same thing we did before. I'm going to sketch a little picture of this. And let's see. I'm going to actually do this on a graph this time. So I've got x and y. So S is 1, 2. So 1, 2 is going to be right there. T is 3, 6. That's right there. U is 6, 7. Right there. And B is 4, 3. That's going to be right there. So let's draw those. And again, this doesn't need to be a perfect picture, but at least it gives you an idea of where everything is. So there's S, there's T, there's U, and there's V. So if that's a parallelogram, that means that opposite sides are parallel. If opposite sides are parallel, they must have the same slope. So there's my plan. That's what I need to work with at the beginning. So I'm going to find the slope of each side in that quadrilateral, and you can catch up with me once I've done that. So I found the slope of ST and UV, and they were equal to each other, so that means that ST is parallel to UV. I found the slope of TU and SV. They were equal to each other, so they're parallel. So therefore we can say STUV is a parallelogram since opposite sides are parallel. Now we'll take a look at part B. So we want to prove that the diagonals bisect each other. So for this one here,
Attention everybody, the cup rally for the Terry Fox run is going on now in the gym. Ice creams for sale. And the color run, those of you who are in it know who you are, will begin at 11:40 on the small field.
okay, so I'm just going to pause it. I got to go get some ice cream. Well, that's some good ice cream. Okay, so I've got my diagram there. If I draw the diagonals then are these two lines. And so basically if SU bisects TV, they will have the same midpoint. Because if they bisect each other, it means that that line segment is equal to that line segment, and it means that that line segment is equal to that line segment. So if that's the case, that point in the middle has to be the midpoint of each of those lines. So I'm going to go ahead and find the midpoint of TV and the midpoint of SU, and we'll compare them. I'll be right back. So I've calculated the midpoint of TV and the midpoint of SU, and they are the same point, 3.5, 4.5. So that means that the diagonals therefore do bisect each other. Okay, so for the last two, I'm going to let you guys try those on your own, and then we're going to discuss them as part of the warm-up in class tomorrow. So you see if you can figure out C and D there, and then I'll catch up with you on this stuff tomorrow.